Hello, my name is Juan Reina. I am taking General Biology 1406 Section 4 for the spring semester. I'm going to be teaching you about the atom, maybe its basic structure, the orbitals, the quantum energy levels, and then the type of bond that atoms go through, experience, how atoms interact, the type of bonds they react with. So, an atom is the basic unit of matter. It consists of three subatomic particles, that's the proton, neutron, and electron. They dictate the electron dictates how reactive an element will be. For example, here lithium, here's the nucleus, the circle in the middle, and then it's the little dot in between this in the middle of the circle, center of the circle, and the first energy level, which is the first circle around the nucleus, has 2 electrons, and then the one in the second circle, that's where the outermost electron is, and that electron would dictate lithium's activity. Or this electron in general, for any outermost electron, will dictate any atom's reactivity. So that's what an electron does. Okay, and basically, like, electrons are usually held in orbitals, and orbitals are just really the place where you will most likely find an electron. Like it's the probability of finding an electron in this place, in orbital. And then the atoms have different shells. For example, like there's the S shell, atom S shell, P shell, D shell, and F shell. The S shell only has 1 orbital. P shell has 3 orbitals, D shell has 5 orbitals, and the F shell has 7 orbitals. And each one orbital can only contain a maximum of 2 electrons. So S shell can have 2 electrons, P shell can have 6 electrons, D shell can have 10 electrons, F shell can have 14 electrons, excuse me. And the S shell is very low in energy, and it goes up. As you go from S to F, the energy increases. S shell is very, very low energy. So, now we're going to talk about the type of bonds atoms go through. So we have an ionic bond, which an atom transfers an electron to another atom. For example, sodium chloride. Another way of describing ionic bonds are like a metal and a non-metal. And they're usually a full charge with ionic bonds. They're perfect solids and they're very polar. Okay. Let's talk about covalent bonds. It's usually in this one, an atom shares electrons with another atom. And it usually happens if the species that interact in covalent bonds are non-metal, either non-metal and a non-metal. Okay, and for example, like water, H2O, or CH4, methane, those are examples of covalent bonds. And in H2O though, it's a polar. And then CH4 is non-polar. The reason for this is H2O doesn't share the electrons equally, because oxygen has a high electronegativity, and H doesn't have that much. So oxygen will pull the electrons more towards itself. So the electrons are shared unevenly. For methane, it's non-polar because they share the electrons equally. Because like carbon and hydrogen, their electronegativity difference is not too high, it's not a huge difference. So that's why they share their electrons equally. So that's a covalent bond. And then there's hydrogen bond. Hydrogen bond, it involves hydrogen, and in order for hydrogen to happen, the hydrogen must be attached. The hydrogen must be attached to an electronegative atom, and that hydrogen must be attracted to an electronegative atom. So that's basically what hydrogen bonding is really, and it gives water its properties. Gives water its properties. So here's an example of hydrogen bond. So, and here's another water right here. right here. Okay. So excuse me, sorry about that. So the hydrogen here wants to be attracted to the electrons here. So the hydrogen is attached to an electronegative atom, and it's attracted to the electrons, or to the oxygen here. It's attracted to the oxygen here, or the oxygen here is attracted to this hydrogen right here. Okay, so the hydrogen here is attached to an electronegative element, but it's attracted to an electronegative element. That's really what hydrogen is, and it gives water its properties like cohesion, adhesion, and cohesion could be like surface tension. It makes water hard. It makes water like it allows insects to step on it. Then there's adhesion, which is water attracted to itself, to other stuff. I'm sorry, excuse me. For example, like capillary action. That's a good example of adhesion. And so these are the three bonds that atoms can go through. There's also metallic bonding, but that won't really be discussed here in this video. And so that's pretty much it for this video. Thank you for listening, and thank you.